In this lesson, we will solve radical equations. A radical equation is an equation in which the variable is hiding inside a radical symbol in the radicand. For example, this is a radical equation, radical x plus 3 equals 10, but x plus radical 3 equals 10 is not a radical equation because the variable is not in the radicand for this equation, but it is for this one. So the 4 steps for solving a radical equation are: number 1, isolate the radical. Number 2, square each side. Or in general, raise each side of the equation to the reciprocal power of the radical to undo the radical. Number 3, solve for the variable. And number 4, check the solution in the original equation to determine if there are any extraneous solutions. Example 1. First thing you want to do is isolate the radical. So here we're going to get the radical expression by itself. We're going to add 5 to both sides. When we do this, we end up with radical 3 plus x equals 3. Next step, we want to undo the radical by squaring both sides, because this is a square root, so we'll square both sides. So we square both sides, remembering to put both sides in parentheses, and we end up with 3 plus x equals 3 squared, which is 9. So as you can see, the square and the square root cancel each other out, therefore leaving 3 plus x by itself. We subtract 3 from both sides, we end up with x equals 6. Finally, we do the check step, since we've just solved for x. And the check step, just like we did with absolute value equations, you always plug back into the original equation. So we'll take 6, plug it back in for x over here. 3 plus 6 is 9. Square root of 9 is 3, and 3 minus 5 is negative 2, which checks out. So 6 is a legitimate solution. Next one, isolate the radical. Subtracting 2 from both sides, we end up with radical x plus 3 equals 4. Let's undo the radical by squaring both sides, like so. And we end up with x plus 3 equals 16. Subtract 3 from both sides, x equals 13. Plugging back into the original equation, radical 13 plus 3 is radical 16, which is 4, and 4 plus 2 equals 6. So this also checks out. Let's take a look at another example. So here, the radical expression is already isolated. And if you notice, this is a little different. We have a binomial on the other side of the equal sign. What you must remember is when you square both sides, you're squaring the binomial x minus 1. Not the individual terms, you're squaring the entire binomial. That's why we get into the habit of putting parentheses around the binomial. Therefore, it forces you or reminds you that we're actually foiling here. First is x squared, outer terms and the inner terms combine to give me negative 2x, and the last term is positive 1. Over here, 5x minus 9 escapes out of the radical sign. So now we are going to solve a quadratic. Every time you see an x squared, you should recognize this as a quadratic. Subtract 5x from both sides, add 9 to both sides, we end up with this quadratic equation. X squared minus 7x plus 10 equals 0. This is factorable. X minus 5 times x minus 2. So our solution set is 5 and 2. Always do a check step. Here we have to do two check steps because we have 2 possible solutions. So here we have x equals 5 and x equals 2. Plugging back into the original equation, we have 5 minus 1, which is 4, equals 5 times 5, which is 25, minus 9, which is 16 under the radical. And as you can see, this will work out because the square root of 16 is 4, and 4 equals 4. Give that a check mark. That works out. X equals 2. Plugging in, we have 2 minus 1, which is 1. And over here, we have 5 times 2 is 10 minus 9, which is square root of 1, which evaluates to 1, and therefore 1 equals 1. and this checks out as well. Both solutions are good. Okay, we're trying to get some variety here. Let's look at number 4. We have radical x plus 1 equals x minus 1. As you can see, the radical is already isolated. Let's skip to step 2. Undo the radical by squaring both sides. So we square both sides. The square is going to cancel out the square root, leaving x plus 1 equals, and once again we must FOIL the binomial, x squared minus 2x plus 1. We want to collect all of our terms and variables to one side, leaving 0 on the other, minus x minus 1, minus x minus 1. We end up with this quadratic equation, 0 equals x squared minus 3x. As you can see, we can factor out x. The greatest common factor of both of these terms is x. We factor it out, we end up with x times x minus 3. And therefore, the two solutions, possible solutions, are 0 and positive 3. Now on to the check step. We're going to check 0, we're going to check 3. Plugging into the original equation, 0 plus 1 equals 0 minus 1. Radical 1 equals negative 1. And you should see that this is not going to work out because positive 1 does not equal negative 1. So we know that 0 is an extraneous root. Let's try 3. 3 plus 1 is 4, 3 minus 1 is 2, and radical 4 is 2. 2 equals 2, and this checks out. Therefore, the only solution is 3. 0 is extraneous. Number 5. When we subtract 8 from both sides in order to isolate the radical, we end up with square root of x plus 4 equals negative 1. Now, this is similar to solving absolute value equations. You must stop here and say no solution because a radical equation never equals a negative number. And we can justify this graphically. So if you plug this into your graphing calculator, radical x plus 4 as one equation and negative 1 as our other equation, when we graph, we can see that negative 1, the line y equals negative 1, is down here, the horizontal line, and our radical equation, y equals radical x plus 4, is this curved line up here, this curved graph here. As you can see, it stops here on the x-axis, never intersecting the line below, and therefore there's no solution. Okay, last example. As you can see, we must isolate the radical, so we're going to subtract 4 from both sides. When we subtract 4, we get negative 3 on the right. On the left side, please do not forget that this subtraction sign is actually a negative radical. So, just like we've done before, we must eliminate the invisible negative 1 here by dividing both sides by negative 1. And this will give us radical 2x minus 5 equals positive 3. Squaring both sides, we end up with 2x minus 5 equals 9. Add 5 to both sides to get 2x equals 14. Dividing by 2, x equals 7. Let's go ahead and do the check step. Plugging in 7 for x, we end up with 2 times 7 minus 5 under the radical. 14 minus 5 is 9, and radical 9 is 3. 4 minus 3 gives us 1, and 1 equals 1. So as you can see, 7 checks out as our only solution for this radical equation. Good luck to you.